All right. So, hello everyone. My name's Luke Ditria. I'm here in Melbourne, Australia, where it's currently just after 1 a.m. Um, I'm really excited to just briefly show what I've been up to and what I do. Um, so, as Tali introduced, I'm going to be talking about some of my experience building edge compute devices with a sort of ecology conservation twist. So, my background is in electrical and computer systems engineering. I have a PhD in computer science in applications of deep learning here at Monash, at Monash University here in Melbourne, Australia. And that was also a part of the Australian Centre for Robotic Vision, where we use cameras to help robots find things, right, as a primary sensor. Um, my PhD wasn't really related at all to ecology. It was kind of conceptual or theoretical. But during that time, unrelated to my thesis, I was actually put in contact with some ecologists up in Queensland at Griffith University who were experimenting with a bunch of techniques that some of you are probably familiar with, using deep learning based object detection to process large amounts of footage that they collected from the field. So in this example here, they were using GoPros underwater to collect video of fish, and then take that terabytes of data back and try to filter that out, detect this fish, count them, and potentially do species classification. There were other projects on environment utilization, beach utilization, doing detection and tracking that I was helping them with as well. Um, so while helping them through these projects, I was also thinking about other ways we could use technology. And I have a lot of interest in using low power edge compute devices to do the processing. So instead of collecting the data on device, taking it back to a server and then processing it there, we can record and process the data on device. So what I'm talking about is continuous real-time edge compute, where we're doing the processing on the device in real time, continuously. And that kind of started this whole series that I've been working on and posting on YouTube, where I'm been slowly over the last 12 months developing these devices and sharing it with the community. Maybe some of you have seen them. So about 12 months ago, I started putting together a device, the goal being to use object detection models running on a little NVIDIA Jetson Nano module to see if we could create a device that we left outdoors, just in the backyard, running continuously with object detections, shut down, start up, and collect data that way. So this first design was very rushed, put together in about a week, but it did sort of prove a concept that we could build these devices and had some learnings from that. From there, I looked at other technology that we could use, other devices that we could use to run our object detection models. I was aware of a whole range of what I'd call inference-only neural network accelerators, which we'd use to run our deep learning models. So Raspberry Pi actually released two modules or two accessories to the Raspberry Pi, the AI hat and the AI camera. The AI hat here uses the Halo 8 neural network accelerator. So I built a second device based on that, a little sleeker, a bit faster, fixing some of the bugs and issues of the older devices. So again, this is the Halo accelerator. If you're interested, again, I have more details in the YouTube videos if you want more on that. So I started to add some additional things. I've got an SSD here and connected the Raspberry Pi via 4G so that we're able to now deploy this in a remote location and actually send the detection data over 4G. So all the processing is done on the device, but we're just sending the actual results over 4G so we can log them in a cloud server. So I had this on a remote property and was just detecting kangaroos here. So again, all the processing is happening on the device. It's being logged and saved on the device, and the raw detection data is being sent over 4G. At the same time, I had a lot of interest from people wanting to build their own. This device here was a little pricey. The hardware itself is probably 600 US dollars altogether, not including the solar panel in the box. So I developed a smaller version based on the Raspberry Pi AI camera. It's small and compact, again, self-contained, powered by some lithium-ion batteries, and the Raspberry Pi Zero. And again, that works pretty similar. All the processing is happening on the device. And I've recently also released a build video for that device. So if you're interested, the GitHub links there, all the code and the files are available for that as well. So in the last few months, I've been starting to take this a bit more seriously and taking all the information I've learned from the last 12 months that I've been developing this sort of part-time, and I've created the latest version, which is fully 3D modeled and 3D printed out of ASA, with high power solar charging and large capacity batteries. We've also developed our own PCB carrier board for the Raspberry Pi that has 4G LoRa, some switchable outputs, and the high capacity solar charging. I've also got another version here with an external battery pack with a big lithium iron phosphate battery and a camera with infrared lights. So this is for full 24-hour operation. And we're currently going to be trialing that here in Victoria on some projects. So hopefully some real world projects. Finally, there's been a lot of interest in the solar charging aspect of that board. So we're actually developing a Raspberry Pi hat that has high capacity solar charging for large lithium iron phosphate batteries. So if you're interested in that, you can stay tuned. And I'm pretty much on all socials. So I cross post all my content across all the socials. So you can pick your poison and reach out or stay tuned there. Thanks.
Amazing. Thank you so much, Luke. We had some enthusiasm in the chat. Super exciting. And it's great to see what an accessible way you're sharing this in. I was thinking of questions like, are you teaching people how to build their own? And then you answered a lot of those throughout. So that's great. I'm curious, what are some of the use cases that you're most excited about that you think this is really going to be game changing for?
Yeah, so the main reason I'm really interested in the edge compute aspect, processing data on the edge, is that we can now deploy it in really remote locations where network connectivity might not be the strongest, eventually even underwater. So back to the fish project, that takes a bit more doing though. So putting it in environments continuously for months or years, and just being able to collect the data with low bandwidth communications. And there are some other projects that we're sort of collaborating with at the moment. I can't go into too much, where you want a quick response time. You want the detections instantly. You don't want to have to wait to transmit the data to the cloud and come back. Yeah.
Amazing. Well, thank you so much, Luke. If anyone has more questions for Luke, feel free to pop them in the chat and hopefully he can help address them there. Thanks.
Thanks.